Hello, welcome to video 1 of 2.7. We found in the previous videos that there is a shortcut to finding the derivative function, but it only works for power functions. So this very first part of our notes sheet here reminds us that previously when we learned the power rule for derivatives for power functions, we hopefully remember that this rule can only be applied if, number one, the base is a variable, and we mostly saw it with the base being x. And number two, the power or the exponent has to be a constant. A constant meaning just a number, right? So those two things is what I have to have in order to take the derivative using the power rule. So normally, for example, we said y equals x to the seventh. I can do that because I can use the power rule because I have a power function. I know it's a power function because my base is a variable, my exponent is a value, a constant, a number, however you want to see it. Or I could have f of t equals t to the 1/2. Well, there again, I have a variable for the base and I have a number or a constant for the exponent. So as long as I have those things, and as long as the power function is not in the denominator, I can't take derivatives in the denominator, then I can use the power rule. Unfortunately, we aren't only using power functions, right? There's different types of functions. And so the purpose of this topic 2.7 is to introduce you to 4 new shortcuts that we're going to use for the derivatives of sine, the derivative of cosine, the derivative of e to the x, which is the exponential function, and the derivative of the natural log of x, which is the natural logarithmic function. I'm going to give these to you without proof. I'm not going to show you how to figure them out using the limit definition. It can get pretty hairy, and we just don't have the time to invest. I think it's more helpful to learn how the shortcut rule works, and then we can apply it to different situations. So these 4 are the ones we're going to deal with. So f of x is, if f of x is sine x, the derivative of sine x turns out to be cosine x. That's pretty straightforward. Here's where you have to be careful. If my original function is cosine x, the derivative is not sine x. It's actually the opposite, or negative sine x. Later, in one of the later topics, when we talk about trigonometric functions, we're going to find there's a nice pattern that we can use whenever we're dealing with cofunctions like cosine. My favorite function of all is e to the x. Its derivative is e to the x. And the derivative of the natural log, that's an L, natural log of x, is 1 over x. So these are 4 shortcut formulas that you're just going to have to memorize. You're just going to have to know going in. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of e to the x is e to the x. And the derivative of the natural log of x is 1 over x. Now, later, we're going to find out that we can use these base shortcut rules even if we get something like the sine of the square root of t. We'll still be able to use the basic derivative function rule that we just wrote in this table. We're going to have to do a little bit more, but you'll find that it's not that bad. So if you remember, i.e. if you memorize these 4 shortcut rules, it's going to make your life a lot easier. At the end of today's videos, I'm going to put a bonus video, not because it's you earn bonus credit, but if you're interested in being convinced, it won't be like a full proof, but if you're interested in being convinced that these are the derivatives as I say they are, I'll put it in that video so that you can see. So how do we use this? Well, I'm going to do a couple of problems here in this first video, then we'll pause and we'll do some more examples in the second video. So something like number A here is pretty straightforward. Remember that there's a rule that says if I'm multiplying by a constant, if I'm multiplying a function by a constant, when I'm looking for the derivative, I can hold the constant and multiply by the derivative of whatever the function is. That only works with constant numbers, values, well, however you want to see them. So I have a 2. I'm multiplying 2 times sine x. I can find the derivative of sine x and then multiply that answer times 2. Well, the derivative of sine x, we just finished saying, is cosine x. So therefore, my final answer is just 2 cosine x. So the constant multiple rule says if you're multiplying by a constant, a number, hold the number, take the derivative of the function, and then multiply it back in. Easy peasy. Things like letter B here, again, straight from the shortcut rules. If I'm taking the derivative of the natural log of x minus cosine of x, well, remember there's a difference rule which says if I'm taking the derivative of two functions that I'm subtracting, all I have to do is take the derivative of the first function minus the derivative of the second function. But be careful, the derivative of cosine is negative sine, and therefore when I simplify this, this is going to equal 1 over x plus sine x. But that is my derivative function. So instead of using that limit definition, the limit of f of x plus h minus f of x all divided over h as h approaches 0, we're able to find the derivative function really quick, so that if I do ask you to find the derivative at a specific point, we can definitely do that using this function. Let's do one more and then we'll pause. I think I'd like to do maybe letter D. Letter D or letter F? Actually, let's do letter F. I think that one's a little bit more involved. Oh, I didn't even see that fourth part there. All right. So before I take the derivative, I notice, hey, I could use the power function, the power rule for this, because this part is the same thing as 1/2 times x, right? I could also use the power rule for this because this is the same thing as x to the negative 1. And then when I look at this function, just like I did with this one, whenever I'm dividing by a number, I'm really multiplying by the reciprocal of that number. So see how I was dividing by 2? That's really multiplying by 1/2, right? If you cut something into two parts, that's like saying I'm taking half of that thing. Well, the same thing here. I'm dividing cosine x by 3. That's the same thing as 1/3 cosine x, and then minus e to the 4. That doesn't change for a couple of reasons. So here we go. We're going to take the derivative. For the first part, we can use the power rule. The power rule says take your exponent, multiply it as the coefficient, times x to the new exponent, and the new exponent, we subtract 1 from the original one. So negative 1 minus 1, that would be negative 2. Plus, I can use the power rule here because I have an exponent. Even though I can't see it, there's an exponent of 1. So I can multiply 1 times 1/2 x, and then if I subtract 1, well, that's going to be x to the 0. And in effect, that means it disappears because anything to the 0 power is 1. So 1/2 times 1 means this is gone. Plus, I have 1/3 times cosine x. There's that constant multiple rule that says if you're multiplying by a number, hold the number, take the derivative of the other part, and then multiply it times the number. So the derivative of cosine x is negative sine x. So this is going to turn maybe into negative or minus 1/3 cosine x minus the derivative of e to the 4th. Now here's where some students, if they're not paying attention, can get confused because you look at e to the 4 and you say, oh, the derivative of e to the x is e to the x. So the derivative of e to the 4 is e to the 4, but it's not, because e to the 4 is a constant. And whenever we take the derivative of constants, that's 0, right? This number doesn't change. E to the 4 is a number, it's a value, and it doesn't change. So therefore, the rate of change, the instantaneous rate of change, the derivative is 0. So this would be the answer, but let me write the multiple choice version of that answer. Remember, multiple choice options usually don't have negative exponents, so we're going to flip it back down, and this is going to be negative 1 over x squared plus 1/2 minus 1/3 cosine of x. And I would say this might be the multiple choice answer. All we're doing is applying new derivative shortcut rules to functions that are maybe looking more to be more complicated, but now finding the derivative is not as complicated.